So one thing that we will observe is that many ionic compounds will contain what we call polyatomic ions. So what are polyatomic ions? Well, they're different from monatomic ions in that they are ions that are composed of more than one atom. So a polyatomic ion is formed from a group of atoms that are held together by covalent bonds that has lost or gained one or more electrons. So there are only three common polyatomic cations. These are the ammonium ion, the mercury 1 ion, and the hydronium ion. And the ammonium ion, NH4+, is particularly common, and the hydronium ion is probably slightly less commonly observed. And the mercury 1 ion, I don't think I've ever seen a problem involving the use of the mercury 1 ion for that's relevant to our class. There are many more polyatomic anions, and a significant number of these include oxygen in their structure along with one or more other atoms, and these are referred to as oxyanions sometimes, or also oxoanions. So you'll see that terminology a little bit. So a whole bunch of these polyatomic anions. There are 10 common ones that you're probably going to end up memorizing. The ammonium ion is the most common polyatomic cation, and then there are a bunch of others. Some of them contain oxygen and are oxyanions. Some of them are not in that category, and I'm thinking here of the cyanide anion in particular. There's a really big list on page 113 of your text. You should just have that handy when you need it. Okay, so how do you name a compound that contains a polyatomic ion? Well, it's just like any other ionic compound. You write the name of the cation first, followed by the name of the anion, and your big decision here is, does my cation require Roman numerals or not? So when I look at this guy, the first thing that I look at is, what is my first element? What is my cation? And I'm like, yay, it's sodium. It's in group 1A. It's a fixed charge cation. No Roman numerals required. So there's my metal, there's my cation. So that means that all that remains must be my anion. It must be a polyatomic anion. So this guy is containing 2 sodium ions, each with a charge of +1. I know that because these guys in group 1A all form cations with a +1 charge. And then it's got one of these carbonate ions, which are a polyatomic anion, right? So to name this compound, we give the name of the cation followed by the name of the anion. So this is called sodium carbonate. We name it just like any other ionic compound by giving the name of the cation and following that with the name of the anion. How did I know that this was a carbonate ion? I looked it up in my table. Okay, if there's more than one of a polyatomic ion, in a formula you put the ion in parentheses and then you put the multiplier, the number that it's being, the number of that ion that there is outside of those parentheses. So when I see something like this, I know that my cation is the ammonium ion, and there are 2 of them, right? And then that gives me a total charge of +2. And then here's my anion, CO3 2-. There's one of those. It gives a total charge of -2. And then you add that together, 0. Right? So this contains 2 polyatomic ions, 2 ammonium ions, and 1 carbonate ion. How do we name it? You give the name of the cation followed by the name of the anion. So this is called ammonium carbonate. I've mentioned this previously. We never use Greek prefixes when we're naming ionic compounds. So this is not diammonium carbonate. It's just straight up ammonium carbonate. Okay, so one of the topics in ALEX that you're going to be asked to complete is predicting the formula of ionic compounds that contain polyatomic ions. So you're going to want one of these tables of common polyatomic ions. There's many of them online. You can use the one that's in the book. So it says write the empirical formula, that means give the lowest ratio of ions, for at least 4 ionic compounds that could be formed from the following ions. So when you look through here, you see that there are 2 cations, and they're going to be what your formulas begin with, right? And so the cations can be combined with anions. So let's combine it with this guy. Now, as they have equal and opposite charges, it's going to just give me NH4IO3. Don't put it in parentheses if there's only one of the ion. Okay, now there's another anion that the ammonium ion could combine with, NO3 minus. And again, equal and opposite charges, so they combine 1 to 1. Okay, what about Fe2 plus? Well, Fe2 plus can combine with IO3 minus, and they don't have the equal and opposite charges, so I'm going to need 2 IO3s and 1 Fe3 plus. So Fe parentheses IO3 2. You see that? When you have more than one of the polyatomic ion, it goes in parentheses. And then Fe2 plus NO3 minus. They don't have equal and opposite charges, so I need 2 NO3 minuses and 1 Fe. So again, FeNO3 2. Alright, so I didn't actually use my tables of ion names, but those ions are in there. NO3 minus is the nitrate ion, and then IO3 minus is the iodate ion. And of course we had ammonium NH4 plus, there it is. Alright, not too bad. Okay, so that concludes this very short section on naming compounds containing polyatomic ions.